This video is about metallic bonding. That is, bonding in a pure metal. So that's either a metal where all the atoms are the same metal, like gold or silver, or an alloy, which you will recall is a blending of metals, where the metals haven't undergone a chemical reaction, but the atoms are interspersed with each other, each metal retaining its own properties. Okay, in a metal, you have a lot of nuclei that are very close together. And each of these nuclei have electrons associated with them. Think about what we learned last chapter about orbitals. Because these nuclei are so close together, the orbital that contains this electron that is around this nucleus overlaps with this orbital that contains this electron around this nucleus, etc., etc., etc. So because of that, the electrons are what they call delocalized. Delocalized. What that means is each electron doesn't stay with, quote unquote, its nucleus. It moves around. It travels among all of these overlapping orbitals. Think of a group of children going from house to house to house in the same neighborhood. Right? They don't stay local with their own nucleus. Okay? A lot of times you'll see that referred to as a sea of electrons. Okay? Meaning, of course, that the electrons are freely moving, just like water. Okay? Now, let's think about the consequences of that from a macroscopic point of view. This picture I've just drawn you here is a microscopic picture, a picture, very small scale. But macroscopic is the things we see ourselves that are the properties of metals, the things we can see as when we have a big piece of the metal. So what are some properties of metals? Let's think about that for a minute. Well, for one thing, metals, with one exception on the entire periodic table, metals are solids. That means they have relatively high melting and boiling points. Yes, there's variations within the metals, but as compared to covalent things and ionic things, metals have very high melting and boiling points. Why is that? Well, if you look at this microscopic view, it's because this sea of electrons actually makes a very strong bond. So because the bond is strong, it's hard to break, needs a lot of energy. That means a high melting and boiling point. If you think about the difference between solids, liquids, and gases, liquid particles are more spread out, gas particles more spread out than that, solids very close together. So to spread those atoms out further to make a liquid or a gas, you need to break bonds. And since these bonds are strong, you need to put a lot of energy into it to break those bonds. That's a high melting and boiling point. Another property of metals is that they are malleable and ductile. Malleable, you'll remember, means you can mold it into shape. Ductile, you remember, means you can pull it out into wire. Why is it that metals are malleable and ductile? Well, once again, we look at this picture. Because the electrons are delocalized, because the nuclei are so very close together, it's easy for these nuclei to slide past each other And that's why you can change the shapes pretty well. Okay? Lots of nuclei sliding past each other fairly easily. This is why you need alloys, by the way. Because, like steel, if you think about steel is a harder version of iron. What they do to make steel is they put carbon atoms to make steel. They put carbon atoms in amongst the iron atoms. So you might have these iron nuclei, but you have these littler carbon atoms. Think about trends. Carbon's a lot littler than iron. And these carbon atoms, because they're a different size than the iron atoms, stop that easy movement of nuclei amongst over each other. So steel is harder than iron. It doesn't move as easily. It's not as malleable. It's not as ductile. And that's why we can build skyscrapers. Okay? This is why alloys are important. Another property of metal is it's a good conductor of heat and electricity. Heat is really just energy. So to conduct heat and electricity, what you need is movement. Let's concentrate on the electricity. It's a little easier to think about. To conduct electricity, you need two things. One, you need charges. And two, those charges have to move. Okay? In order to conduct electricity, you need moving charges. Well, this is what I have. This sea of electrons is nothing if not moving charges. The electrons move, and of course we all know electrons are negatively charged. So, because we have this movement of these electrons, these delocalized electrons, that is how electricity and heat are conducted. Metals conduct even as a solid. They're the only things that conduct as a solid, because even as a solid, we have movement. We have movement of electrons. And that's pretty much all you need to know about metals at this point.